Hi, this is Alex from devstories.eu. GeoDjango and PostGIS, episode 11 of 15. You have a database full of massive, complex polygons, and your front end just needs to display a pin at the center of each one. If you fetch those raw polygons into Python to calculate the center, you are dragging megabytes of useless coordinate data across the network. The solution is pushing that math down to the database using geographic database functions. There are two ways to get spatial information like area or a center point in GeoDjango. The first is to query the database record, pull the entire geometry into a Python geos object, and access a property like .area on it. Do not do this unless you actually need the full geometry in Python. Fetching a national park boundary might mean loading tens of thousands of vertices into memory just to calculate a single number. The second, much more efficient way is to tell PostGIS to calculate the answer and only send back the final result. This is where geographic database functions combined with the Django ORM annotate method become essential. Let us look at a practical scenario. You are building an API that lists national parks. For the list view, the client application only needs the park name, its total area, and a single center coordinate to drop a map pin. It does not need the complex boundary polygon. In your Django query set, you use the annotate method. You tell it to create a new attribute, maybe called park area, and set it equal to the area function acting on your geometry column. Next to it, you create another attribute called center point, set equal to the centroid function on that same geometry column. Finally, you restrict the query output to just the name and your two new annotations. When this query executes, PostGIS reads the raw geometry data on disk. It runs highly optimized internal routines to calculate the spatial area and find the mathematical center point. It then returns exactly three things over the network to your Django application: a text string for the name, a number for the area, and a single point geometry for the center. You completely bypass the bandwidth and memory costs of transferring the large polygon. This strategy applies to many spatial operations. You can use the transform function inside an annotation to convert coordinates from your database storage projection directly into the projection your web map needs, like Web Mercator. The database handles the math before Python even sees the data. You can also use the as_GeoJSON function. This instructs PostGIS to format the spatial data into a standard JSON text string directly in the database. When Django receives it, it's just text ready to pass directly to your front end, avoiding Python serialization overhead entirely. You can also apply aggregate functions across entire query sets. The extent function looks at a group of geometries and returns a single bounding box that covers all of them. If a user searches for all parks in a specific region, returning the extent gives you the exact coordinates needed to automatically zoom the front-end map to fit all the results perfectly. Here is the key insight. Your spatial database is a highly specialized computation engine, not just a storage container. Keep your heavy spatial computations inside PostGIS and only move the calculated answers across the network to Python. That's your lot for this one. Catch you next time.